Hello everyone, today I'll cover synchronization and I'll use the producer-consumer problem as an example. In the producer-consumer problem, there's one or multiple producers that produce items and push those items onto a stack or any other shared data structure. And there's one or multiple consumers that consume items from that shared data structure. And so the idea here is that we use synchronization to synchronize access to that shared data structure. At the basic level, we make sure that only one thread can access that shared buffer at any time. In the advanced example, we could make sure that there's only a single producer, but allow multiple consumers at the same time. So let's start out by creating a class that serves as our shared buffer. And inside the class, we use a stack. And the element type, we use items. So the producer will push strings onto the stack, and the consumer will pop the strings off the stack. And then we'll add another variable that serves as our maximum size. So we import the stack here from the java.util package. And we define a constructor that expects the maximum size as argument, and we assign it to the same named member variable. Then we add two methods. One is a add method that adds an item to our buffer. And so here one thing that we want to check is if the buffer is full. In this case, is our stack full? For now, I'm just going to return, but I'm going to update that code in a moment. And if it's not full, if there's space available, we just push that item onto the stack. So what I want to do is, I don't want to return, I want to actually wait. And I want to wait and then continue whenever the size changes. So the idea here is that a producer will wait, then if a consumer comes and consumes an item, it will wake up the waiting thread of the producer and say, hey, check again, I removed an item, you should be able to push a new item onto the stack. So the way we do this, we start out by using the synchronized keyword on the method, and this guarantees that there's only a single thread at a time inside that method. And for that matter, it actually synchronizes on the object of the buffer here. So if I have multiple synchronized methods, there can only be a single thread in any of the synchronized methods at any given time. So the next thing here I want to do is, I call the wait method. This will essentially pause the thread and wait until it is woken up. And the interrupted exception, it could be interrupted for any unknown reason, so we don't really know. So when it wakes up, we do want to check again if the size actually changes or if the buffer is still full. So we flip our if condition to a while loop. That way we check it, and if we wake up, we check it again and see if it actually changed. If it didn't change, we just wait again. So what happens here is, when a thread calls the add method and enters the add method, it will require the lock. There's a single lock on this object, and the object is also called the monitor. So it acquires the lock. It will lock. When we call the wait method, it actually releases the lock. So that means another thread can enter the method at that time, and it will require the lock as well. If it waits, it will also release the lock. So there could be any number of threads waiting here. And later we'll wake up the threads. There will be one thread of the waiting threads that will be woken up, and it'll check again. So if it wakes up and the size in fact changes, it'll continue, push an item onto the stack, and then it will call notify. And notify call is again on the current object. So when we wake up here, we get the lock again, we acquire the lock, we check, push an item to the stack. When we call notify, we release the lock. And that is all we need here. Now we add a second method, also synchronized. This one we'll just call consume. This will consume an item. And here we need to also check. We kind of follow the same pattern, but the condition that we use here is we check if it's empty, while stack.isEmpty. And if it's empty, we wait. Now again, we need to surround it by a interrupted exception. So if we wake up, we check again if it's empty. If it's no longer empty, we get out of the while loop, and then we can consume an item. So we do stack.pop, and here we also call notify. So notify only calls a single thread that is waiting. There's another method called notify all. That will wake up all threads. But in this case, we really just want to wake up a single thread to check again. And then at the end, we return the item. Now, synchronized here is synchronized on the current object. Sometimes your methods are really long, so you don't want to synchronize on the full method, because there might be just a small part inside the method that needs to be synchronized. In that case, what you can do is you can do synchronized, and then on any object that you want synchronized. You could do this. So this again on the current object, but now I use a different syntax. And I don't need synchronized here on the method anymore. So I could do it like this as well. I could have instructions now before the synchronized block that is not synchronized. So as soon as I enter the block, that will be synchronized. And again, I can synchronize on any object. It shouldn't really be strings, but in general, any object that you can think of. Now let's add a producer class. And that producer we implement runnable. So runnable has a single method called run. And here what we'll do is we want to continuously produce items. And we simulate that producing an item takes some time. So we wait for a random amount of time. So we create an object of type random. And then I create an integer that just serves as a counter for our items that we produce. And then we continuously loop and create items. Now I mentioned we want to kind of simulate that it takes some time for items to be created. So here we sleep for a random amount of time. And the 1000 is in milliseconds, so we wait a random amount of time between 0 milliseconds and 1000 milliseconds. And whenever we wake up, we call here our buffer that I still need to add up here, and we produce that item. So let's create the buffer here. And the buffer we pass into the constructor. And so we can access the buffer here and add a new item. So we call it item, and I use my counter variable, the integer. And then after that I increment it for the next item. So here let's initialize it to 0. To actually let's do 1. So we sleep for some time when we generate a new item. When we simulate to generate a new item, then we call buffer add. We add an item, we give it the number, which item it is. So initially it's 1, we increment it, and then will be item 2, item 3, item 4, and so on. And this is all we do in the producer. Now similarly, we'll create a consumer. So call it consumer. This also implements the runnable interface. And inside this run method, we do similarly like we did in the other method. Now the consumer also needs access to the buffer, so I create a buffer variable, and this buffer is passed into the constructor. So let's pass it in here and assign it. And now again, we wait for a random amount of time, so we create an object of type random, and then we continuously consume items from the buffer. So we do first thread.sleep, wait for a random amount of time, this one in a try catch block in case there's any interruption. If there is, it doesn't matter, it's just like we randomly slept for 0 milliseconds or anything shorter that we maybe intended to sleep, so that is okay. And now we consume an item from the buffer. So we call consume, and that is it. Now one thing, let's actually go back into the buffer and output some information here. So here we do system.println push item. So this is the item we're pushing onto the stack, and after we consume it, we also output consume item. That's the one that we are consuming. Now there's one more class that I create, which is the main class that has the main method inside. And here we create a buffer, and I just initialize it of size 10, and then I create 2 threads. So one is the producer thread, and the thread expects a runnable object, so we implemented the runnable interface, so we can create a producer here, and we pass the buffer to the producer. Then we create another thread, consumer thread, and we create a consumer and pass the buffer to the consumer. And next we start these threads by calling the start method. I have a typo somewhere there, or actually up here, so it should be thread with an R. Okay, and then consumer thread, same thing, we start the consumer thread. And this will trigger the continuous loop. Now, whenever you have threads, always call the start method. Don't make the mistake and call the run method. It should really be the start method, and internally it creates a new thread that calls the run method. If we call the run method instead, it would just be a normal method call. It wouldn't actually create a new thread. So let's run this and observe the output. So we can see some items get pushed, sometimes multiple items in a row, sometimes it's kind of consume, and push. Here were like 3 of them that got pushed, but everything is now synchronized with our access. So the synchronized block here synchronizes on the current object, and the method also on the current object. So there can be only one thread in this block or one thread in this block. And that is all about synchronization. I hope you understand the basic concept on synchronization in Java now. Thank you for watching.